some simplest radical form. Hopefully you kind of saw these before. So here are some properties of square roots, okay? And you have to know how this works. If I had the square root of any two numbers, the square root of A, some number times the square root of B, I can rewrite that under the same radical, okay? Square root of A times B. Everybody got that? And I can also do it with dividing. If I have the square root of A divided by the square root of B, I can rewrite it as the square root of A over B. And vice versa, right? Equal signs work both ways, don't they? Right? So if I had the square root of A times B, could I rewrite it like that? Yeah, because equal signs go both ways. Similarly for this, I could rewrite it like that, okay? Now, very importantly, you see this over here? This property does not work with addition or subtraction. You know that little plus minus symbol, right? Plus or minus either. This only works with multiplication and division. Okay, you can only do this stuff, combine them like that, or break them up like that with multiplication or division, not addition or subtraction. Okay, everybody got that? All right, so here's some examples. If I have the square root of 4 times the square root of 3, that becomes the square root of 4 times 3, which is what? Square root of 12. Okay? If I do the square root of 50 over the square root of 2, I can use this division property, square root of 50 over 2, but what's 50 divided by 2? And what's the square root of 25? 5. Hey, 25 is a perfect square, isn't it? You know what a perfect square is? When you take the square root of it and you get a nice whole number, right? Anything that's not a perfect square can take the square root. You get an irrational number. What's irrational?
A decimal that doesn't stop.
Never ends and never repeats, right? Goes on forever. But a perfect square, when you take the square root, you get a whole number. So what you'll need to have in your head is a list of perfect squares. So it's that when you take the square root, you get a whole number. Well, how do you make perfect squares? Well, you take whole numbers and you square them. So let's go through this list. For example, 1 squared is what? 1. What is 2 squared? Okay? Because so now 4 is a perfect square, isn't it? Because what's the square root of 4? What is 3 squared? 9. 9 is a perfect square because what is the square root of 9? 3, a nice whole number. You get the idea? And 4 squared is what? 16. 5 squared, right? You'll need to know this list. And then 36, 49, yep, 81, 100, 121, 44, 169, 196, 225, 256, 289, 324, 361, I think he's right, yeah, and 400, and it goes on and on, right?
I did this in my head.
Yeah, well, that'd be good to know, right?
Well, it's good.
Now, until you have these solidly in your head, you can always reproduce this list pretty easily, couldn't you? You know, you might need your calculator next to you, okay? But you can reproduce this fairly easily. So let's take a look at some of these perfect squares to see what happens when we take the square root. 121. What is the square root of 121? 11, a nice whole number. What's the square root of 144? And the square root of 36? Okay? So we're going to combine the concept of these perfect squares, right, this list of perfect squares, with these properties up here to write things in simplest radical form. To be in simplest radical form means that the number under the square root does not have any perfect square factors in it. We will have taken out the perfect square factor and taken the square root of that factor and put it on the outside. You see what I mean? So simplest radical form. We want to take the number and factor out the largest perfect square factor. The largest of these lists of numbers here, that's a factor of the number that's under there. Okay? Sometimes there will be more than one of those. It's a factor of that number, but you want the largest one. Okay? So let's look at an example. So the square root of 80, okay? What would be the biggest perfect square factor of 80? In other words, which of these perfect squares that we calculated is the biggest number that goes into 80? what you could do is use your calculator and start doing 80 divided by, I would start high and go low, because you want, which one? The biggest. Thomas? Okay, you want the biggest one. So I might start doing 80, well, I'm not going to divide it by 100, right? I'm not going to divide it by 81. 80 divided by 64, right? Is not going to go in too well. So maybe 80 divided by 36. Do that right now. Do 80 divided by this perfect square, 36. What do you get? A decimal. You're looking for a whole number, right? Right? So let's do 80 divided by 25. You probably already know it's not going to work, but you get a decimal, right? So 25 is not a perfect square factor. How about 80 divided by 16? 5. 16 is a perfect square. What's the square root of 16, guys? 4. So let's rewrite this square root of 80 using that multiplication property, right? Going this way. Wouldn't this be my 80? 16 times 5. So I'll write it as the square root of 16 times the square root of 5. I've taken out that perfect square. That's the biggest perfect square factor of 80. You got me? And what is the square root of 16? So the square root of 80 is 4 square roots of 5. See how that goes? You saw this in algebra, right? Probably not enough to be proficient at it, okay? Let's look at another example. Square root of 52. The largest perfect square factor of 52. And once you do a bunch of these, you won't have to go to your calculator. You can start dividing 52 by perfect squares. Listen, you're not dividing by these numbers, are you? These are not the perfect squares. 5, 6, 7. When you square, these are the perfect squares that you're dividing by. Okay? And you want the largest factor of that. So for 52, the largest perfect square factor is what? Say right there. 4. 4 times what gives you 52? What is it? 13, you mean? So I can rewrite the square root of 52 as the square root of 4 times the square root of 13. What's the square root of 4? 2. 2 square roots of 13. So the 13 stays under the square root, right? Because it's not a perfect square. We don't take it out of there and get some obnoxious decimal. We leave it in there, right? But the perfect square comes out. Let's try, here's one slightly different, okay? So we got the square root of 2 times the square root of 14. Neither of them are perfect squares. But let's multiply them. What's 2 times 14? So I can rewrite that as a square root of 28. Now, what's the biggest perfect square factor of 28? Yeah, well, 4 is, right? So I can rewrite square root of 28 as the square root of 4 times the square root of 7. You with me? And what's the square root of 4? So it's 2 square roots of 7 equals the square root of 28. Starting to catch on here? No? Oh, well, okay. Well, anyway, you guys try these down here, 1 through 5. There's a 1 through 5 in your book because there was a discrepancy. Right? You got 5 of them? Okay, right. All right. So take a minute, show your work here. You probably want to work vertically. So square root of 50. What's the biggest perfect square factor of 54? Which of these is the largest one that goes into it? 9 times what? So we could rewrite this as a square root of 9 times the square root of 6, right? And then I'll put my equal sign down here. You'll have an equal sign as well because you connect everything with an equal sign. What's the square root of 9, guys?
3.
Square root. So it's 3 times what? Square root of 6. No, I can't do 3 times 6. No, you don't multiply into that with the 3. You follow me? It's just 3 times the square root of 6. You cannot multiply back into that with that number that's out there. You got me? You understand that?
Yeah.
I can't call this the square root of 18 because I can't do 3. It's not 3 times 6. It's 3 times the square root of 6. It's a different thing altogether. All right, so take a minute and finish these out. So what'd you say you got? You got square root of 20? 3 square roots of 20 is that 7?
Yeah.
Okay. And so you said 9 was the biggest perfect square factor, 180, right?
I was wrong.
Is there a bigger perfect?
30.
No, 30 is not a perfect square. 36 is a perfect square, isn't it? Does it go into 180? How many times?
5 times.
So this would be the square root of 36 recording, times the square root of 5, right? And what is the square root of 36? 6 square roots of 5. How many got that? Okay? You want the biggest perfect square factor, that number. Now, Trent, you could have, just for giggles here, you had, you don't have to write this down, you had 3 square roots of 20? Okay, so if you wanted to proceed from there, let's think about what's the biggest, you can still get there. What's the biggest perfect square factor of 20? 4 times what? 5. What's the square root of 4? See what's going on here? And what's 3 times 2? So we do get 6 square roots of 5, but it's kind of obnoxious, right? Okay? That's why you want to find the biggest factor to start with.
Wasn't wrong, was it?
Hmm? You weren't quite completely finished. Put it that way. Okay? All right, work on the rest of these here. What did we get for number 3, children?
5 times the square root.
How many got 5 times the square root of 2? All right, so we combine these first, right? So that became the square root of what? Am I recording? Yes. So square root of 50, and then we broke that into the biggest perfect square factor of 50 is what? 25 times 2, which equals 5 square roots of 2. Okay? Circle these answers here. How about number 4? What'd you get, Vicar? How many got 4 times the square root of 3? Okay. So we did 6 times 8, right? And you got the square root of 48. And what's the biggest perfect square factor of 48? The biggest one.
60.
Right? Maybe you found that 4 was, right? But there's a bigger one. So it'd be square root of 16 times the square root of what? 3. And what is the square root of 16? 4 square roots of 3. Did we get the last one yet?
I found out what to do. I didn't.
So let's just take the 2 and the 4. What's 2 times 4? We'll leave that out here for now. And now take the 5. And now what's 5 times 15? 8 times the square root of 75. We're going to leave the 8. The 8 can't go inside there. Everybody got that? You don't multiply the 2 into the 5 or the 4 into the right square root of 15.
Square.
You'd have to square. You'd have to make that the square root of 4. You like work it all backwards. Don't. But then you're going the opposite direction you want to go, right? You'd have to do it that way. All right. So leave the 8 out here. The 2 times 4 out here for now, right? 8 times. What's the biggest perfect square factor of 75? 25 times 3. See, my 8's still hanging on, just for the ride here right now. Okay. So what's the square root of 25? So we have 8 times 5 square roots of 3. And that becomes what? 40 times the square root of 3. Get the idea there? So these multiples outside, you just multiply them and let them go along for the ride as you do, apply your properties to
I
square
got the
roots.
square root of 20 times the square root of 24.
Oh, that sounds like a big mess. Okay?
Fun.
All right, let's go down here. So here's a thing you cannot ever do in that. You cannot leave a radical in the denominator of a fraction. You can't have the square root in the bottom of a fraction. In other words, you don't want to be divided by a square root of anything. Okay? But we have a little technique we can use to rationalize denominators. Right? Because the square root of a non-perfect square is irrational, right? Right? That's one goes on for repeating, okay? Well, here's how it looks. So let's say I have the square root of 35 over 15, right? If I can, the first thing I should do, and it won't always work, the first thing I should do is try to put this, whatever it is, in lowest terms. It's going to be easier to work with. So if I divide top and bottom by 5, I get the square root of 7 over 3, right? Yeah, everybody with me? Now let's apply that division property. This becomes a square root of 7 divided by the square root of 3, right? Now I cannot have, in math, a radical down the bottom of a fraction. You might wonder why that is, right? It's back and forth calculators, right? You'd be dividing by a decimal that goes on forever and never repeats. And you know that little algorithm you do with the division symbol, it goes in and add and carry this over. Where would it, you never even know where to end, right? Divided by something that doesn't ever end, okay? So we want to get the square root out of the bottom. So look what we do. That's the square root of 3, right? So I'm going to take this fraction right here, and I'm going to multiply it by what? 1. What's the square root of 3 divided by the square root of 3? 1. Any number divided by itself is 1. So you guys see I'm multiplying by 1, right? So if I'm multiplying something by 1, am I changing its value? I am not. It's the same value, isn't it? So here's the distinction, though. This particular form of 1 will get rid of the square root in the bottom. Okay? What is the square root of 7? Fractions when you multiply, right? You multiply across the top and across the bottom. What's the square root of 7 times the square root of 3? Square root of 21. What is the square root of 3 times the square root of 3? Which is? You see that? There's 2 ways to look at that. Let me take this. Let me take this. Square root of 3 times the square root of 3. We can look at this 2 ways. By our first property up there, that becomes a square root of 9, right? Which is what, guys? 3. And there's no more square root there, right? You with me? Thomas? You glaze over easily, don't you? Here's another way to look at it. Square root of 3 times the square root of 3 is, well, if I multiply any number by itself, that's called doing what? Like 5 times 5. What is that called? What am I doing to the 5? Squaring it. So square root of 3 times the square root of 3, wouldn't that be the square root of 3 squared? And what does squaring do to square root? It undoes it, and I'm just left with 3. No radical. So 2 ways to look at that. We got that? So that's why I multiply by the square root of 3 over the square root of 3. With me on that? Okay, let me work you through the first example. You guys have 3 examples here? Okay, good. We got to fix that. So let's do the first thing. We got the square root of 6 over 12. Can we put it in lower terms?
Yes.
So we could rewrite it as the square root of what over what? Okay, that's going to make things easier, right? Now what's my second step? Use this division property this way and do what to it? Okay, make it so rewrite it. It's going to equal what? Over the square root of 2. All right, but what's the square root of 1, guys? That's a question. What's the square root of 1? 1, right? Okay. Let me just do that. Equals 1 over the square root of 2. Okay? But I have a square root in the bottom. What should I multiply by to rationalize that?
Square root of 2 over square root of 2.
Okay, and that's exactly right. A lot of kids will say multiply by the square root of 2. What am I actually multiplying by, everybody? No?
1.
What form of 1? Square root of 2, not 2. Square root of 2 over the square root of 2. Right? Right? Why do they pick the square root of 2? Well, over here was the square root of 3. Why do they pick the square root of 2 over here? Because that's what's in the bottom, right? Now let's multiply across the top. What is 1 times the square root of 2? What? Square root of 2. What's going on out there? What is the square root of 2 times the square root of 2?
Square root of 4, which is 2.
Just 2. That's why you did it. And see, no more square root in the bottom. Okay?
Sure, not.
All right. Now, the second one, like the first couple steps are already done for you. Right? So you're just going to take this and multiply it by something. Okay?
I know.
Okay. You guys take a minute and see if you can work these two things out.
Square root of 8. Yeah.
Just say it. What you get?
No. I got it all.
What you get? Just say it.
16. No.
Why you get so scared?
I got 8 over 16 over 4 square.
You got 16 over 2?
16 over
16 over square root of 2? Oh, what's the square root of 16? Well, we're not quite there yet, though. Okay, what did you multiply by here? Square root of what? 2 over square root of 2. Now, 8 times the square root of 2 is not the square root of 16. Remember, you can't take the 8 and put it inside there. So it's just 8 square roots of 2, right? Okay? So it's 8 square roots of 2 over what? No. Square root of 2 times the square root of 2 is what? Which is 2. Right? But we can simplify it one more time, can't we? What's 8 divided by 2? So what's the answer? 4 square roots of 2. So 8 over 2 simplified. Yeah, guys, a lot of you are going to try to do like that. 8 will not go into the radical like that and make it a square root of 16. It doesn't work that way, okay? The only way that works, look, the property's up here. It's got to be the square root of something times the square root of something. Not like a regular number times the square to put them together like that, okay? With me on that? Okay, let's try this last one. Try the last one. So we might do 5 square root of 6 over the square root of 3 multiplied by something.
Chicken patty and salad.
Let's get something. Let's multiply by square root of 3 over square root of 3. 5 times the square root of what? 18 over what? 3. Well, can we simplify that square root of 18 anymore? What's the biggest perfect square factor of 18?
9.
You always want to look, right, and see, is there a perfect square factor, the number under there? So this could be rewritten as 5 times the square root of 9 times the square root of what? 2 over 3, which equals 5 times what? 3 square roots of 2 over 3. Do I need to do 5 times 3 is 15?
Yes.
Or could something cancel right now? You could, or could something cancel?
3.
Won't the 3's just cancel? I mean, you could make it 15 square roots of 2 over 3, and then 15 divided by 3 is 5, right? And so this equals what?
5 square root.
Okay. There's another way to do this, by the way. Can I show you? I don't know, maybe you missed it. Sometimes there's more than one way to skin a badger with these things. Okay?
Why are we skinning that?
Why not?
They don't taste that good.
Who's eating them? All right, so try this. Let's take the square root of 6 over square root of 3 and apply that division property to it. Okay. Can I do that by the division property at the top of the page? You with me? Okay, guys, what's 6 divided by 3? How about that? Anybody catch that? No?
But I like to do it complicated.
No, either way. Right, but when you start doing a bunch of these, you'll start seeing things like that. Right? You're praying for what? Do what? Praying for the what? No. Why? How are you gonna learn how to do these then?
But we only do one half.
No. Okay,
Yeah.